Imagine a colossus at the heart of the early universe, a black hole so voracious that it seems to defy the very laws of physics. A giant capable of devouring material at an unprecedented speed, as if engaged in a never-ending cosmic feast. This is the black hole LID 568, one of the most astonishing recent revelations in astronomy. Not only is it impressive due to its size and growth rate, but it also raises profound questions about how such cosmic monsters could form so early in the cosmos. In this video, we're going to explore the mysteries behind LID 568, the black hole that challenges our understanding of the universe. We'll answer questions like, how could it have become so massive in such a short time? Why does its existence defy everything we know about these cosmic giants? And will it one day devour Earth? Could it be the reason for the end of the world and everything we know? The universe's most voracious black hole. To grasp the significance of this discovery, we need to delve into the concept of a supermassive black hole. Black holes like LID 568 are immense concentrations of matter that sit at the center of many galaxies. They are so massive, with such intense gravitational force, that not even light can escape them. In the case of LID 568, we're talking about a black hole so distant that we are seeing it as it was when the universe was only 1.5 billion years old, an era when we didn't expect to see objects this massive. What's astonishing about LID 568 is the speed at which it grows. While black holes typically grow at a moderate pace, limited by the amount of matter they can absorb, LID 568 exceeds what we call the Eddington limit by 40 times. This limit acts like a natural brake. Upon reaching a certain absorption rate, a black hole should slow down its growth due to the radiation it emits. However, LID 568 is devouring material at such an extreme rate that it seems to completely ignore this cosmic brake. It's a behavior never before seen at this scale. The James Webb Telescope and the discovery of LID 568. The detection of LID 568 would have been impossible without the James Webb Space Telescope, a revolutionary tool for exploring the early universe. Equipped with the latest technology, Webb can observe in the infrared spectrum, enabling it to capture extremely distant and ancient objects. But how far are we talking? LID 568 is approximately 13 billion light-years away from Earth. This means we're seeing this black hole as it was around 13 billion years ago, when the universe was less than 10% of its current age. In other words, we're observing a relic from the cosmos's earliest days. Thanks to its integral field spectrograph, the Webb telescope allowed astronomers to detect gas flows rapidly swirling around LID 568, clear evidence of a black hole undergoing accelerated growth. This discovery was possible because James Webb can see the early universe, a period so distant that visible light from these objects can't reach us. Instead, Webb captures radiation in infrared wavelengths, revealing details about structures like LID 568 that would be invisible to other telescopes. This cosmic giant was so faint and distant that without Webb's advanced technology, its existence would still be hidden. Through this powerful tool, scientists now have a window into epochs when the universe was just beginning to form its first structures. And LID 568 may be only one of many massive black holes waiting to be discovered, inviting us to peer deeper into the cosmos's past. If you're enjoying the video, don't forget to leave a like and subscribe to join the family of universe. The mystery of super Eddington accretion. Here's where things get really intriguing. The Eddington limit sets the point at which a black hole should slow down or halt its matter absorption due to the pressure of the radiation it generates. This limit relies on a balance. As the black hole absorbs more material, it emits radiation that, theoretically, pushes back against incoming material and slows its growth. LID 568 defies this theory, and does so on an epic scale. How does LID 568 break this limit? Scientists believe it might be experiencing what they call super Eddington accretion. This means the black hole is absorbing so much material so quickly that radiation pressure isn't enough to slow it down. It's as if it were in a feeding frenzy, swallowing vast amounts of gas and dust in a short time. This phenomenon opens the door to new theories, suggesting that black holes in the early universe could have grown far faster than we ever thought possible. Additionally, this extreme rate of growth hints that black holes like LID 568 don't just grow steadily, but can go through explosive growth periods. A single event of rapid feeding could transform a moderate black hole into a true cosmic powerhouse in a few million years. Origins and mysteries of the early universe. If LID 568 grew this fast and to this size in such a short time, then the early universe was a more chaotic and dynamic place than we thought. To form a black hole of this size, scientists think it must have started as a heavy seed. Some theories suggest that in the early days of the universe, massive gas clouds could have collapsed directly to form black holes without an intermediate stage, such as a star. This would explain how objects like LID 568 achieved such incredible size in such an early cosmic era. This theory makes us rethink everything we know about the evolution of early galaxies and black holes. Perhaps in the universe's beginnings, these supermassive black holes formed much faster and more frequently than we ever imagined, and their presence may have influenced the evolution of the first galactic structures. If this hypothesis is correct, it means that the early universe not only contained the first stars and galaxies, but also massive black holes capable of shaping their surroundings. This discovery redefines the image of the early universe as a place of calm and expansion, showing us instead a scene of colossal collisions, gravitational collapses, and frenzied black hole growth. What LID 568 tells us about the future of astronomy. The discovery of LID 568 is just the beginning of a new era in black hole studies and the evolution of the universe. The technology of the James Webb Telescope is pushing our observational capabilities to new limits, and each discovery raises new questions about how these cosmic monsters grew and their role in forming galaxies and large-scale structures. LID 568 raises a fundamental question. Is it unique, or are there more black holes like it in the early universe? If we can detect more of these superaccumulators of matter, we might redefine our understanding of black hole growth and the history of matter in the cosmos. In other words, LID 568 is not just an astronomical object. It's a doorway to questions and discoveries that could revolutionize our understanding of the universe. LID 568 is a reminder of how vast and mysterious our universe truly is. It shows us that even the rules we thought were fixed can be challenged at the edges of the cosmos. This voracious black hole not only pushes the boundaries of human knowledge, but also drives us to keep exploring and asking questions. How many other hidden mysteries await discovery? Where will human curiosity take us in this endless journey? Thank you for joining me on this adventure through the mysteries of the cosmos. If you've made it this far and haven't subscribed yet, what are you waiting for? On Universe, you'll find even more quality content, and we'll be thrilled to have you here. Leave a comment with your thoughts on the topic and a like on the video. See you next time.